Picture this, a single moment in the vastness of space where a star, not just any star, but 100s of times more massive than our Sun, reaches the end of its life. In an instant, it doesn't just fade away, it explodes with a force so unimaginable that it outshines entire galaxies. This is a hypernova, one of the most extreme and awe-inspiring events in the universe. To put it into perspective, the energy released in that single explosion is equivalent to the combined output of billions of suns burning for billions of years. It's not just a star dying, it's a cosmic spectacle that reshapes the very fabric of space and time. But what exactly is a hypernova, and why does it hold such incredible power? In this video, we'll dive into the science behind these colossal explosions, explore how they shape the universe, and uncover why they're so much more than just a flash in the cosmic dark. Stick around, because by the end of this journey, you'll see the universe in a whole new light. Now turning to the science behind hypernova, let's explore what sets them apart from regular supernova. While both are explosive deaths of stars, hypernova are on an entirely different scale. A regular supernova occurs when a star, typically around 8 to 15 times the mass of our Sun, exhausts its nuclear fuel and collapses under its own gravity. The resulting explosion is powerful, but a hypernova takes this to an extreme. Hypernova are born from stars that are at least 30 times more massive than our Sun, and sometimes even hundreds of times larger. When these colossal stars reach the end of their lives, their cores collapse with such intensity that the explosion releases energy hundreds of times greater than a typical supernova. This isn't just a star dying, it's a star tearing itself apart in a cataclysmic event that can outshine entire galaxies for a brief moment. The key difference lies in the aftermath. While a supernova often leaves behind a neutron star or a black hole, a hypernova almost always results in the formation of a black hole. This is because the core collapse is so extreme that not even the dense structure of a neutron star can withstand it. The sheer force of the explosion also produces something extraordinary: gamma-ray bursts. These are the most energetic events in the universe, and they're like the hypernova's signature, signaling its presence across vast cosmic distances. So, while a supernova is a spectacular event, a hypernova is a cosmic powerhouse, reshaping the universe in ways we're only beginning to understand. Now turning to the birth of a hypernova, let's dive into the extraordinary conditions that make these cosmic events possible. Hypernova don't just happen to any star, they require the most massive stars in the universe, those that are at least 30 times heavier than our Sun, and sometimes even hundreds of times more massive. These stars are the true giants of the cosmos, burning through their nuclear fuel at an astonishing rate. Their immense size means they live fast and die young, with lifetimes measured in just a few million years, compared to the billions of years our Sun will shine. The life cycle of these massive stars is a dramatic one. They start off as clouds of gas and dust, collapsing under gravity to ignite nuclear fusion in their cores. For millions of years, they burn brightly, fusing lighter elements into heavier ones. But unlike smaller stars, which eventually settle into a stable phase, these giants face a far more explosive fate. As they exhaust their fuel, their cores become unstable, unable to support the crushing weight of their outer layers. This is when the critical moment arrives. The core collapses, triggering a hypernova. What makes this collapse so spectacular is the sheer scale of the energy involved. The core doesn't just implode, it rebounds in a violent explosion that rips the star apart. This isn't just a star dying, it's a star obliterating itself in a burst of energy so intense that it can outshine entire galaxies. And here's something truly fascinating: hypernova are incredibly rare. In a galaxy like ours, they might occur only once every few 100,000 years. Yet, despite their rarity, their impact is profound. These explosions scatter heavy elements like gold, platinum, and uranium across the cosmos, seeding the universe with the building blocks of planets and even life itself. So, while the birth of a hypernova is a fleeting moment in cosmic terms, its legacy is eternal. These titanic explosions shape the universe, creating black holes, triggering star formation, and enriching the cosmos with the elements that make up everything we see around us. It's a reminder of just how dynamic and interconnected the universe truly is. Now turning to the energy release of a hypernova, let's break down just how staggering these cosmic explosions truly are. When a hypernova occurs, the energy unleashed is almost beyond comprehension. In just a few seconds, a hypernova can release more energy than our Sun will produce over its entire lifetime, a span of 10 billion years. To put it another way, the energy output of a hypernova is equivalent to the combined energy of billions of stars like our Sun, all exploding at once. It's a level of power that defies imagination. To give you a sense of scale, let's compare a hypernova to a regular supernova. While a supernova is already one of the most energetic events in the universe, a hypernova takes it to an entirely new level. A hypernova can be up to 100 times more powerful than a typical supernova, releasing energy in the form of intense radiation, shock waves, and gamma-ray bursts. These gamma-ray bursts are particularly fascinating. They are some of the most energetic phenomena in the cosmos, capable of traveling billions of light-years across the universe. In fact, a single gamma-ray burst from a hypernova can outshine an entire galaxy for a brief moment, lighting up the darkness of space like a cosmic flare. But how does this energy compare to everyday phenomena? Imagine the energy released by the largest nuclear bomb ever detonated. Now multiply that by a factor of millions, and you're still only scratching the surface of a hypernova's power. It's like comparing a firecracker to a volcanic eruption. There's simply no comparison. The sheer scale of a hypernova's energy release is so immense that it can reshape the surrounding space, triggering the formation of new stars and even influencing the evolution of entire galaxies. What's truly remarkable is how brief this energy release is. While the explosion itself lasts only a few seconds, the effects ripple across the cosmos for millions of years. The shockwaves from a hypernova can compress nearby gas clouds, igniting the birth of new stars. At the same time, the heavy elements forged in the explosion are scattered far and wide, enriching the universe with the building blocks of planets, moons, and even life itself. It's a fleeting moment of destruction that gives rise to creation on a cosmic scale. So, while the energy release of a hypernova is unimaginably vast, its impact is equally profound. These explosions are not just moments of destruction, they are catalysts for change, shaping the universe in ways that echo across time and space. And as we continue to explore the cosmos, hypernova remind us of the incredible forces at work in the universe, forces that both destroy and create in equal measure. Now turning to gamma-ray bursts, let's explore the deadly signature of a hypernova. These bursts, often referred to as GRBs, are some of the most energetic events in the universe, and they are intimately connected to hypernova. When a hypernova occurs, it doesn't just release energy in the form of light and shockwaves. It also produces incredibly powerful gamma-ray bursts. These bursts are like cosmic lightning bolts, shooting out beams of high-energy radiation that can travel billions of light-years across the universe. What makes gamma-ray bursts so fascinating is their sheer intensity. In just a few seconds, a single GRB can release more energy than our Sun will emit over its entire 10 billion-year lifespan. To put it into perspective, the energy of a gamma-ray burst is so immense that it can outshine an entire galaxy, even if only for a brief moment. This makes GRBs some of the brightest and most energetic phenomena ever observed in the cosmos. But how do we detect these bursts? Thanks to advanced space telescopes and satellites, scientists can observe gamma-ray bursts from incredible distances. These instruments are designed to pick up the high-energy radiation emitted by GRBs, allowing us to study them in detail despite their fleeting nature. In fact, gamma-ray bursts are so powerful that they can be detected from the farthest reaches of the universe, giving us a glimpse into the most extreme events in cosmic history. However, gamma-ray bursts aren't just awe-inspiring, they also pose potential dangers. If a GRB were to occur relatively close to Earth, the effects could be catastrophic. The intense radiation from a gamma-ray burst could strip away Earth's ozone layer, exposing the planet to harmful ultraviolet rays from the sun. This could lead to mass extinctions and disrupt the delicate balance of life on our planet. Fortunately, the likelihood of a nearby gamma-ray burst is extremely low, as these events are rare and typically occur in distant galaxies. Still, the possibility serves as a reminder of the immense power of hypernova and the unpredictable nature of the universe. Gamma-ray bursts are not just a byproduct of hypernova, they are a testament to the incredible forces at work in the cosmos. These bursts remind us that the universe is a place of both beauty and danger, where the same events that create can also destroy. As we continue to study gamma-ray bursts, we gain a deeper understanding of hypernova and the role they play in shaping the universe. And while the dangers of GRBs are real, they also highlight the resilience of life on Earth, which has endured countless cosmic challenges over billions of years. Now turning to the aftermath of a hypernova, let's explore one of its most dramatic consequences, the birth of a black hole. When a hypernova occurs, the core of the massive star collapses under its own gravity, creating an object so dense that not even light can escape its pull. This is the moment a black hole is born, marking the end of the star's life and the beginning of something entirely new and mysterious. The process begins with the star's core, which can no longer support itself against the crushing force of gravity. As the core collapses, it forms an incredibly dense region known as a singularity. Surrounding this singularity is the event horizon, the point of no return where gravity becomes so strong that nothing, not even light, can escape. This is the defining feature of a black hole, and it's what makes them so fascinating and so difficult to study. But the story doesn't end there. As the star's outer layers are blown away in the hypernova explosion, some of the material doesn't escape the black hole's gravitational pull. Instead, it forms a swirling disk of gas and dust called an accretion disk. This disk orbits the black hole at incredible speeds, heating up to extreme temperatures and emitting vast amounts of energy. In some cases, the energy released by the accretion disk can outshine entire galaxies, making these systems some of the brightest objects in the universe. Hypernova play a crucial role in seeding the universe with black holes. These cataclysmic events are responsible for creating some of the most massive black holes we know of, including those found at the centers of galaxies. Over time, these black holes grow even larger by consuming nearby matter or merging with other black holes, shaping the structure of the cosmos on a grand scale. The formation of black holes from hypernova is a reminder of the dual nature of the universe. Destruction and creation are often two sides of the same coin. While a hypernova marks the end of a star's life, it also gives rise to some of the most enigmatic and powerful objects in existence. As we continue to study these cosmic phenomena, we gain not only a deeper understanding of black holes, but also a greater appreciation for the dynamic and ever-changing nature of the universe. Now turning to another fascinating aspect of hypernova, let's explore how these colossal explosions contribute to the cosmic chemical evolution of the universe. Hypernova are not just about destruction, they are also cosmic forges, creating and scattering some of the heaviest elements in existence. This process, known as nucleosynthesis, is what fills the universe with elements like gold, platinum, and uranium, which are essential for the formation of planets, life, and even the technology we use today. When a hypernova occurs, the extreme temperatures and pressures generated during the explosion trigger a series of nuclear reactions. these reactions fuse lighter elements like hydrogen and helium into heavier ones. In the heart of the collapsing star, elements such as carbon, oxygen, and silicon are forged. But the real magic happens in the outer layers of the star, where the intense energy of the explosion creates even heavier elements, including gold, platinum, and uranium. This process is known as rapid neutron capture, or the R process, and it's one of the most efficient ways to produce these rare and valuable elements. Once these heavy elements are created, the hypernova explosion propels them outward at incredible speeds, scattering them across vast regions of space. Over time, these elements mix with interstellar gas and dust, becoming part of the raw material for new stars, planets, and even life. Without hypernova, the universe would lack many of the elements that make up the world as we know it. For example, the gold in your jewelry or the uranium used in nuclear reactors likely originated in the heart of a hypernova billions of years ago. Hypernova play a crucial role in the cosmic cycle of matter. They recycle the remnants of dead stars into the building blocks of new ones, ensuring that the universe remains a dynamic and ever-changing place. This process of creation and destruction is a testament to the interconnectedness of all things in the cosmos. As we study hypernova and the elements they produce, we gain a deeper understanding of our own origins and the intricate processes that shape the universe. With this in mind, it's clear that hypernova are not just spectacular displays of cosmic power, they are also essential contributors to the chemical richness of the universe. Next, we'll delve into the challenges astronomers face in observing these rare and distant events, and the groundbreaking technologies that are helping us unlock their secrets. Now turning to the challenges and breakthroughs in observing hypernova, let's explore why these cosmic events are so difficult to study and how modern technology is helping us overcome these obstacles. Hypernova are incredibly rare, occurring only a few times in a galaxy over the span of 1 million years. This rarity, combined with the vast distances that separate us from these explosions, makes them exceptionally challenging to detect and analyze. Most hypernova occur in distant galaxies, millions or even billions of light years away, meaning the light we observe today actually left the star long before humans even existed. One of the biggest hurdles astronomers face is the sheer unpredictability of hypernova. Unlike some astronomical events that can be forecasted, hypernova occur without warning, leaving scientists with only a brief window to capture data before the light fades. To make matters more complicated, the intense gamma-ray bursts that often accompany hypernova can outshine entire galaxies for a few seconds, but they are fleeting and difficult to catch in action. This means astronomers must rely on a combination of luck and advanced technology to study these events. Fortunately, recent advancements in observational technology have revolutionized our ability to study hypernova. Space telescopes such as the Hubble Space Telescope and the James Webb Space Telescope have provided unprecedented views of distant galaxies, allowing scientists to detect the faint afterglow of hypernova long after the initial explosion. These telescopes can peer deep into the universe, capturing detailed images and spectra that reveal the chemical composition and dynamics of these cosmic events. Another groundbreaking tool in the study of hypernova is the detection of gravitational waves. When a massive star collapses to form a black hole or neutron star, it sends ripples through space-time known as gravitational waves. Instruments like the Laser Interferometer Gravitational Wave Observatory, or LIGO, have made it possible to detect these ripples, providing a new way to study hypernova that complements traditional light-based observations. By combining data from gravitational waves and telescopes, scientists can piece together a more complete picture of what happens during these cataclysmic events. These technological advancements have not only made it easier to detect hypernova, but have also deepened our understanding of their role in the universe. By studying the light, gravitational waves, and chemical signatures of hypernova, astronomers can uncover clues about the life cycles of massive stars, the formation of black holes, and the origins of heavy elements. As we continue to refine our tools and techniques, the mysteries of hypernova are slowly being unraveled, bringing us closer to understanding the extreme forces that shape our universe. With these breakthroughs in mind, we can now explore how hypernova influence the evolution of galaxies, shaping the cosmos on a grand scale. Now turning to the impact of hypernova on galactic evolution, let's delve into how these colossal explosions shape the very fabric of galaxies. Hypernova are not just spectacular cosmic events. They are also powerful agents of change, influencing the structure and evolution of galaxies in profound ways. One of their most significant roles is in triggering the formation of new stars. When a hypernova explodes, it sends shockwaves rippling through the surrounding interstellar medium, the vast clouds of gas and dust that fill the spaces between stars. These shockwaves compress the gas, creating dense regions where gravity can take over, pulling matter together to form new stars. In this way, hypernova act as cosmic catalysts, sparking the birth of stellar nurseries across galaxies. But the influence of hypernova doesn't stop there. These explosions also play a crucial role in redistributing matter throughout galaxies. The immense energy released during a hypernova scatters heavy elements like iron, gold, and uranium far and wide. These elements, forged in the hearts of massive stars and ejected during the explosion, become part of the interstellar medium, enriching it with the building blocks for future stars, planets, and even life. Over time, this process of cosmic recycling shapes the chemical composition of galaxies, ensuring that each generation of stars and planets is more diverse and complex than the last. Hypernova also leave their mark on the structure of galaxies by shaping the interstellar medium itself. The shock waves and radiation from these explosions can carve out vast bubbles and cavities in the gas and dust, altering the density and temperature of the surrounding material. These changes can influence how stars form and evolve, creating regions of intense star formation or, conversely, suppressing it in others. In some cases, hypernova can even trigger a chain reaction of star formation, as the shock waves from one explosion compress nearby gas clouds, leading to the birth of new stars, which may eventually explode as hypernova themselves. To visualize these processes, imagine a galaxy as a dynamic, ever-changing ecosystem. Hypernova are like the storms that sweep through this ecosystem, stirring up the interstellar medium, redistributing matter, and triggering new cycles of star formation. Over billions of years, these explosions help shape the spiral arms of galaxies, the distribution of stars, and even the formation of galactic clusters. They are a driving force behind the evolution of galaxies, ensuring that the cosmos remains a place of constant transformation and renewal. As we continue to study hypernova and their impact on galactic evolution, we gain a deeper appreciation for the interconnectedness of the universe. These explosions remind us that even the most destructive events can give rise to new beginnings, shaping the cosmos in ways that are both beautiful and profound. With this understanding, we can now explore how hypernova have been portrayed in science fiction and popular culture, bridging the gap between scientific reality and creative imagination. Now turning to the realm of science fiction and popular culture, let's explore how hypernova have captured the imagination of storytellers and creators across various media. In movies, books, and video games, hypernova often serve as dramatic symbols of ultimate destruction or cosmic power. These fictional portrayals, while sometimes exaggerated, draw inspiration from the awe-inspiring reality of these cosmic events, blending scientific concepts with creative storytelling to captivate audiences. In many science fiction narratives, hypernova are depicted as cataclysmic events capable of wiping out entire civilizations or reshaping the fate of galaxies. For example, in some blockbuster films, hypernova are used as plot devices to heighten tension, often serving as the backdrop for epic battles or the driving force behind a race against time to save humanity. These depictions, while thrilling, often simplify the complex science behind hypernova, focusing instead on their visual spectacle and emotional impact. Books, particularly in the science fiction genre, have also embraced hypernova as a way to explore themes of survival, resilience, and the fragility of life in the universe. Authors use hypernova to create scenarios where characters must confront the sheer scale of cosmic forces, often leading to profound reflections on humanity's place in the cosmos. While these stories may take creative liberties, they often incorporate real scientific principles, offering readers a blend of entertainment and education. Video games, too, have found ways to incorporate hypernova into their narratives and gameplay. In some games, hypernova are used as environmental hazards or as part of the game's lore, adding a layer of realism and depth to the virtual worlds players explore. These depictions can range from scientifically accurate simulations to fantastical interpretations, depending on the game's tone and genre. Regardless of the approach, hypernova in video games often serve to immerse players in the grandeur and danger of the universe. While these fictional portrayals are undeniably compelling, it's important to compare them to the real science behind hypernova. In reality, hypernova are rare and occur at such vast distances that their immediate impact on Earth is minimal. However, their portrayal in popular culture often amplifies their destructive potential, sometimes conflating them with other cosmic events like gamma-ray bursts or asteroid impacts. This creative license, while entertaining, highlights the gap between scientific understanding and artistic interpretation. Despite these differences, the fascination with hypernova in science fiction and popular culture reflects a deeper human curiosity about the universe and its mysteries. These stories allow us to grapple with the enormity of cosmic events in a way that feels personal and relatable, even as they stretch the boundaries of scientific accuracy. By blending imagination with reality, creators help us envision the unimaginable, sparking wonder and inspiring a deeper appreciation for the science that underpins these awe-inspiring phenomena. As we reflect on the portrayal of hypernova in fiction, we're reminded of the power of storytelling to bridge the gap between the known and the unknown. These narratives not only entertain but also invite us to ponder the profound questions that hypernova raise about the nature of the universe and our place within it. With this exploration of hypernova in popular culture, we now turn to a pressing question: could a hypernova ever threaten Earth? Now turning to a question that often sparks both curiosity and concern: could a hypernova ever threaten Earth? To answer this, let's first consider the likelihood of such an event. Hypernova are incredibly rare, occurring only in the most massive stars, which are themselves uncommon in our cosmic neighborhood. The nearest stars capable of producing a hypernova are located thousands of light years away, making the chances of a hypernova occurring close enough to affect Earth extremely slim. However, if a hypernova were to occur relatively nearby, its effects would depend largely on the distance and the alignment of its gamma-ray burst or GRB. Gamma-ray bursts are among the most energetic phenomena in the universe, and if one were directed toward Earth, it could have significant consequences. A GRB from a hypernova within a few thousand light-years could potentially strip away part of Earth's ozone layer, exposing the planet to harmful ultraviolet radiation from the sun. This could disrupt ecosystems, harm agriculture, and increase the risk of skin cancer for living organisms. But here's where Earth's natural defenses come into play. Our atmosphere acts as a shield, absorbing much of the harmful radiation from cosmic events. While a nearby GRB could still cause some damage, the likelihood of it being catastrophic is low. Additionally, the vast distances between stars mean that even if a hypernova occurred in our galaxy, the chances of its GRB being precisely aimed at Earth are astronomically small. It's also worth noting that hypernova and their associated GRBs are not the only cosmic threats we face. Events like asteroid impacts or solar flares pose more immediate and probable risks. Yet, even these are rare on a human timescale, and scientists are actively working on ways to detect and mitigate such threats. So, while the idea of a hypernova threatening Earth makes for gripping science fiction, the reality is far less alarming. The universe is vast, and the distances that separate us from these extreme events provide a natural buffer. By understanding the science behind hypernova and gamma-ray bursts, we can appreciate their power without undue fear. As we wrap up this exploration, let's take a moment to marvel at the resilience of our planet and the protective mechanisms that allow life to thrive in an often unpredictable cosmos. With this understanding, we can look to the stars not with fear, but with a sense of wonder and curiosity about the incredible forces that shape our universe. Now turning to the conclusion of our journey through the extreme power of hypernova, let's take a moment to reflect on what we've learned. Hypernova are among the most awe-inspiring events in the universe, releasing energy that can outshine entire galaxies and shaping the cosmos in profound ways. From the collapse of massive stars to the creation of black holes and the scattering of heavy elements, these cosmic explosions play a crucial role in the evolution of the universe. We've explored how hypernova differ from ordinary supernova, their connection to gamma-ray bursts, and their potential to influence galactic structures. While the idea of a hypernova threatening Earth is a fascinating concept, the vast distances and protective mechanisms of our planet make such an event highly unlikely. Instead, hypernovas serve as a reminder of the incredible forces at work in the universe and the delicate balance that allows life to exist on our planet. As we conclude, let's consider humanity's place in this vast and dynamic cosmos. The study of hypernova not only deepens our understanding of the universe, but also highlights the resilience and ingenuity of life on Earth. These cosmic phenomena inspire us to keep exploring, learning, and marveling at the mysteries that surround us. If you found this exploration of hypernova as fascinating as we did, don't forget to share your thoughts in the comments below. What cosmic phenomenon would you like us to dive into next? Make sure to subscribe and hit the notification bell so you never miss out on our latest videos about futuristic technologies and the wonders of the universe. Until next time, keep looking up.